So he does have a lot of experience, hands-on experience. And I'm not exactly sure how he got into mapping. I think something to do with his education at Chico State. But I think what he's most famous for and almost celebrity status is his website, The Lookout. And The Lookout is amazing. I feel that it contains some of the most collective, accurate, and up-to-date info during a wildfire, and it's all narrated by Zeke in a way that is so easy to understand. And the mapping is amazing. It's really state of the art, gives you a really clear indication of where the fire is, where it's potentially moving, and even he even throws in fire weather information. So okay, it's 9:38 now. We should probably get started. Again, we've asked Zeke to come here today and present on all the information he has about computer fire modeling. I feel it's really important to understand the limitations. It's not going to give you 100% of the answers. I don't feel it's always accurate, but I think Zeke's presentation can help us understand how to better use fire modeling. So I hope that's fairly accurate in my intro for you, Zeke, and I'll let you have the floor.
All right. Thanks for the invite. I'm glad to be here, and I don't often get to talk about all this stuff, so glad to have an opportunity. And Casey got me thinking kind of right off the bat about some things I wasn't really thinking about talking about with modeling. I started my career working for the Forest Service, and then I was getting a geography degree. Originally, I was getting a graphic design degree at Chico State, and I thought, man, if I get a graphic design degree, I'm going to spend my whole life at a computer. So then I got into geography. I took a map and air photo class just kind of on a lark, I think my sophomore year in college, and I thought, wow, you can get a degree in map making at Chico State. So I got a geography degree with a cartography emphasis, and worked for the Forest Service in the summers on a timber marking crew, painting trees for thinning. And then that kind of turned into doing some GIS for the Forest Service, and then turned into doing some work back at Chico State on pre-fire planning. And that was kind of late 90s, and we were looking at watershed conditions around Chico, mainly because we have wild Chinook salmon in the rivers here. And so the person who was supposed to write the fire chapter for this existing conditions report we were doing bailed out, and they said, hey, weren't you on a fire crew? And I've been on 2 or 3 lightning fires. And I said, well, yeah, a little. And they said, well, you're going to write this chapter. And so I started interviewing CAL FIRE people, and it was kind of right when GIS was starting to be used in fire camps, in trailers. People would bring a plotter out in a trailer. And so I kind of just fell into this intersection of fire and technology right when it was really taking off in the late 90s. And we did a little work at that point. With the report I was writing, there was a local fire behavior analyst who did some modeling for us. And basically, the models that we're using are still based on map that was kind of sketched on a napkin at a conference in the 1970s by a guy named Rothermel. That basically is some basic equations that look at how slope and wind affect fire behavior along with fuel loading. And mainly people were interested at first just in, like, if you have a wind blowing across a slope and this much grass, is the fire going to run up the hill or across the hill sideways? So in the late 90s, a guy I was working with took, that program is called Behave, that we use to look at how fuels and weather affect flame length and fire spread. And so people started doing some creative things with taking Behave runs and manually running Behave, for every different condition. Brush on a 30% slope, south facing. So it was cumbersome, but it was kind of the beginning of making this stuff more spatial. The Behave it's just you run an equation and it tells you for this point in time, the fire is going to go this direction at this rate. So the rise of GIS has kind of led to the rise of spatial fire models. And I ended up working for a contractor for about 10 years. And my mentor was a guy who was a Forest Service operations section chief. And he'd been hotshot crew leader. And in the Forest Service, basically, if you haven't spent like 10 years on the hotshot crew, digging line and cutting down snags and sleeping in the dirt, like no one really takes you seriously. If you want to be a fire management officer on a national forest, like unless you've been on a hotshot crew, you're not going to get the job. And so for me, having been on a timber crew and not a lot of suppression experience, we started doing planning meetings for community wildfire protection plans and working with stakeholders that were Forest Service people. And I couldn't really go, even though I could run these models and I could use the tools to build the inputs, I didn't really have that much experience with wildfire. And so I couldn't really stand in front of a room of these fire management officers and say, well, we ran Flam Map and Farsight, and it says the fire is going to be here tomorrow, so you should cut brush over there. But all this modeling work we've been doing for the last 25 years has really been applied to these kind of community scale problems of where do we expect the fire to impact this community? How fast will it spread if it starts on this roadside on this afternoon with these conditions? So I kind of evolved this relationship with my mentor where he could run the models, but I could build them. I could build the inputs, and he could deliver them at a meeting and people would listen to him because he had, 40 years of fire experience. So you could say, well, the model's showing this, but when I was on the Laguna fire in 1978, it actually did that. So, take this with a grain of salt. So over the last 20 years, I've gotten more experience actually with observing wildfire and prescribed burning, and got to a point where I don't need my mentor as much, which is good because now he's really old and kind of doesn't want to stand in front of public meetings and talk about modeling anymore. But the basics, one of the big problems we've got really is that the basic math of how fire spread is still based on these equations developed in the 70s. And also our understanding of how fire spread, it keeps getting blown out of the water every year. Something new happens, some fire does something that really doesn't fit the models at all. So there's some work being done to build new models. The big problem is just that for the most part, everything we're using is still what we call Rothermelian. Like it's based on the work of Rothermel back in the 70s. And I think one of the kind of fundamental problems with modeling in general is that where the models are headed now is more like computational fluid dynamics. And it's really hard to find someone who understands that stuff and has any experience with wildfire. So I think it's kind of this classic problem we have with science is that the more specialized you become and the deeper you become genius, the less likely it is that you have spent time around fire or really understand what the right questions are to ask with modeling. I think the big thing now that's changed for a lot of this is that we have LiDAR, and LiDAR is really changing the game of how we can portray and characterize the fuel loading kind of in a three-dimensional space. So we have landscape scale fires, and we've needed to create landscape scale data sets to run our models. But the only tools we really have for landscape scale mapping are Landsat or Sentinel or other, fairly coarse resolution, quarter acre pixel type applications. And those satellites just don't see through the tree canopy. So we can use satellites to map the canopy closure really well, and we can map tree height. And we can kind of get at species. We can cobble together all the different vegetation mapping that's been done. But none of that really gives us a very good idea of what things are going on in the understory. Looking at the height of the brush versus the lowest branches of the trees. So LiDAR is kind of helping us bridge that gap. One of the problems with LiDAR is just that it's a point in time and it's expensive and it's hard to do a landscape scale acquisition. With Landsat, the thing goes over every 12 days or something and we get a new scene. Sentinel goes over every 5 days. So it's free and you can grab it for last week. LiDAR costs, $2 an acre. And so maybe you get it every 5 years, if you're lucky. Some places don't have any LiDAR at all. So you're all lucky in that you're living in a place that has been peppered with laser beams several times now, and you've got some fairly current data. So I think I'm going to show a little video here about work we're doing in the city of Chico. We're running some fire behavior models in the city of Chico to look at places where the fire can get into town. We haven't talked at all even about this new phenomenon of urban conflagrations. Models are really not working that great in the wildlands. So then when you get into a fire that's being driven by the radiant heat of burning homes, burning cars, the models just fall down. They're not there at all. But I'll talk about, what we've tried to do with the city of Chico is try to narrow it down to what questions do we have about how fires might behave in this wildland urban interface we've got, and then how can we use the models best to help us drill down. International Association of Wildland Fire in Pasadena.
Hey Zeke.
Yeah.
I'm one of the co-hosts. Can you share your screen? Or
Okay.
am I just not getting it on my end here?
I think it should show up with my talking head. Are you seeing it in my kind of talking head space?
I am, yeah. Is that what you'd like to
Yeah,
do?
I'd like to do it in there if I can.
Okay.
Tell me if that doesn't work. But if you can see the video and it's not jerky, I think I'll keep talking.
If you click on the top right, you can change the view to speaker view, and that'll take up your whole screen rather than the gallery view.
Oh, got it. Yeah, that's good tip. Yeah, it's the first time
Oh,
I'm
I see
trying
what
it
you're saying.
this
Yeah,
way.
yeah. Okay.
Okay. All right. So we're going to talk about the city of Chico. It's in the northern Sacramento Valley. It's where I live. And I got to say, it's really a treat to get to do planning in the town you live in and not have to drive and learn a whole new landscape. I've lived here for 30 years. And so, yeah, it's been a treat to work here. We're doing this work for the city of Chico Fire Department. As most of you know, CWPPs are required under the Healthy Forest Restoration Act, federal government, to get funding if you want to do, if you want federal money to do fuels reduction, you need to have a CWPP, which is basically a prioritized list of mitigation projects. So here in the city of Chico, we're up against the foothills of the Sierra Nevada mountains, and there's quite a robust history of fires in the foothills here. We've had the Camp Fire, and we've had fires in 1999 that burned all around town. And until the Camp Fire, we didn't really perceive much of a threat of fires here in the city of Chico. But this blue area shows that the Camp Fire came, after torching Paradise, it came right down into town. Basically, we fought the Camp Fire right on the edge of town. And another thing that the Camp Fire really showed us is just that you can't count on firefighting when a major disaster like this happens. Almost no firefighting happened during the Camp Fire because the firefighters were basically just focused on saving people's lives. In this image, every bright yellow dot is a burning structure. And we burned about 20,000 structures in Paradise in a morning. And for this talk, we were talking a bit about climate change and the context of how it affects our changing risk. So if you look at Paradise before the fire, it was this well-treed, beautiful landscape of shade and kind of refuge from sun. After cleaning up all the lots, it's a completely different landscape. It's open, it's dry, it's exposed to winds. And basically what happened with the Camp Fire is we type converted this kind of forested oak and pine woodland to more of a brush and weed and grass fuel model. And so that's a landscape scale change. The Camp Fire started about 20 miles from Chico in Pulga in the Feather River Canyon, and it burned through an area that had burned in 2018 as well. So basically what's happened now is we've got this kind of type conversion that runs all the way from the Feather River to Chico. And that changes our risk profile in Chico because now we've got more of a chaparral model in the fuels than timber where we had before. So this is flying from the origin of the fire over Paradise towards Chico. You can see this huge spot fire here that was like 2 miles ahead of the main fire. And that's really what we're worried about in town here in Chico. So we keep going here. The red is the edge of the Camp Fire. And now we're into the urban outskirts of Chico, and we have grasslands and riparian fuels and wildland fuels really that extend right into the city. So what we want to do is look at model the fire behavior in the city using LiDAR to create kind of fuel models from the urban vegetation, and then run those models to look at spread vectors, ways that fire can jump through different fuel loadings. And what popped out for us is that there's these neighborhoods the neighborhood on the left is kind of what we call kind of horseshoe properties, where large lots near Bidwell Park, and people who have horses can ride their horses right down the street into the park. But it ends out that that kind of is a corridor, because we've got all these large lots that may or may not have a lot of weeds, to carry fire right into the park. And once fire's in the park, it can kind of go anywhere in town, in the core of town. So these models help us identify our places where you've got kind of contiguous fuels from the park right into neighborhoods or right into areas with large lots. And these parcels shaded in red are parcels that we identified through this process as being higher risk within the urban interface, and also high priority for code enforcement and wildfire outreach. We don't feel like there's a terrible risk to the entire community, but there's these critical kind of pathways where fire can transition from the park into the neighborhoods. And so, you know, the typical approach to drawing a WUI map, urban interface map, is that you draw your wildland areas and then you buffer it half a mile. And then you say, well, this is the WUI and these are the places we're going to do outreach. So another part of the climate change context is just that we've got many, many, many homeless people living in Chico that were displaced by the campfire. So not only have those people had to move out of the foothills, but now they're moving into our parks, and there's a lot of fires being started in the parks. We also have fire adapted ecosystems here that need fire. And so when we're trying to balance our objectives and our hazard reduction and everything else, we have to look at, you know, how can we integrate these management objectives into overall plan. Also, the local Machuca tribe wants to use fire in the parks, and we, our company recently has done a citywide burn plan for the parks to make it easier to do cultural burns. So the modeling, all, you know, there's always different kind of this cultural context behind all the modeling of all these different objectives we're trying to meet, and questions that the models can help us answer towards meeting our kind of cultural and management objectives within, this is right in a neighborhood in Chico. City Fire Department has become really active in burning in the parks. They love it. They haven't for about 20 years, mainly because of budget. You know, for us to burn, we have to bring fire people in on overtime, basically, because they're already at full staffing. So we had a fire in the park last year, a wildfire, and it came down right towards town. And this is kind of one of the scenarios that we want to model. It's like, we know that we have big down canyon winds at night. How can this kind of thing, the things we know about the existing fire regime, how can that help us develop better projects? Also, our modeling had showed us that this part of town was a place that fire could transition from the park right into neighborhoods into Bidwell Park. So we laid out prescribed burn here of 100 acres. Our company wrote the burn plan, and then we helped the city execute it. And when this fire burned, basically, we had this big area of black already on the landscape. And so the firefighters were less worried about it really taking over coming into town. So what we're looking at with the CWPP is how can we do large landscape scale grassland burns on a regular basis to create a buffer around the wildland edge of town and meet all the different objectives that we've got here. The parks director likes this kind of work because it's cheap. You know, it costs almost nothing for her. She might have to pay, you know, $10,000 of overtime to burn 100 acres. But she has to pay $450 an acre to graze it with goats. So it's a lot cheaper. Also, the goats haven't proven to be effective in getting rid of star thistle. So this project here, actually, the biggest objective of this, addition to hazard reduction, is to get rid of star thistle and Medusa head in a really high traffic part of Bidwell Park. So this red area, these parcels, those are the kind of the buffer around town. I'll talk now more about the nuts and bolts of the modeling we're doing. This is Lower Bidwell Park. This is about half a mile from my house. We've got this incredible valley oak overstory, but we also have really heavy understory fuels that are relative of, you know, fire suppression. And this is just what happens in a park when you don't really manage the veg. Poison oak, walnut. So what we did is we took some LiDAR here and we started slicing the canopy into layers. And then for each layer of canopy, we create a grid. This is looking at the bare earth. So take all the vegetation off. And this is looking at counting the density of LiDAR hits or places the lasers hit vegetation in a 5-meter pixel in the first 3 feet. Basically, this is showing us where we've got kind of tall grass, low brush. Then stepping up, these are LiDAR returns between 6 and 12 feet. And so we're creating this 3D kind of stack of slices of the canopy, and those can be used to characterize places that we've got continuous fuel from the grass all the way up into the upper canopy. What this LiDAR slice data is also handy for is characterizing the vegetation. So it's helping us show the fuels, but it's also helping us say, hey, these are the tallest trees. We're going to call this all valley oak, where we've got trees that are over 120 feet tall, or redwood, or whatever else. So the LiDAR is pretty amazing for that. So then we take our historic fire weather here in a couple of different weather stations around town to look at what's our threat scenario. So this is August through November, and you see that we have frequent northeast winds. This is a different weather station at the airport, just on the other side of town, and it doesn't show that influence at all. So just like anywhere else, you have to kind of read between the lines with your weather stations. But we put that all into a fire behavior model called Flam Map, and it shows us here are the places where you've got crown fire hazard in Lower Park. So the problem is that it shows crown fire hazard all over town, mainly because it sees landscaping and it doesn't understand, that this is irrigated stuff in people's yards, or this is, the canopy you're seeing is an oak tree. So that's the problem with the model, is we can't just have the model kick out and say, like, here's your fire problem, because it doesn't really characterize the scenario at all. It shows us where we've got wildland vegetation, and it shows us where we've got pathways that the fire gets spread, but it doesn't, we can't say, we didn't even publish the model results in the report at all, because they just confuse people. They see the whole town's red and they're like, oh my God, I'm not gonna be able to get insurance. And so there we have to just apply a lot of time on the ground and local knowledge. This is kind of the bigger picture view of that crown fire potential. And as you can see, it's like most of the urban interface is saying there's crown fire potential. So we can't publish this map, but we can take these wildfire flow vectors and use them to help us identify those neighborhoods where we see these yellow arrows kind of coming into the neighborhood out of the park. So what we did is basically just drove around to all the places that the model was showing the fire transitioning from the wildland into the urban area to see if that was if it was really a concern. Some places it was, some places it wasn't. Some places there's oak overstory and open mowed grassland. You don't worry about it. But we are most interested in that transition. And this is kind of part of acknowledging that the urban interface spread models just aren't up to snuff. They're not there yet. We can't really, once a fire gets in the neighborhood, we can't really tell you what's going to happen with it. We can look at structure density, and there's a lot we can do as far as kind of outside of the models. There's some good tools for understanding the threat. But see, like here, these show fire into neighborhoods that no one here really expects to ever get wildfire in. And then you see that the ladder fuels are like a well-pruned hedge that has no potential. So anyway, this is kind of our final output product is 3,000 parcels. And then we did mailing to them and surveys. We're still kind of tabulating survey results. One interesting thing about the survey is it found that 99% of the people were all right with prescribed fire in the park. And the biggest deal in the survey was whether people were extremely supportive of prescribed fire or just very supportive. With smoke management, we haven't had that many issues. We're burning light fuels and the wind tends to blow up into the foothills where more people are, and it dissipates really quickly. But things that we expected to be obstacles to putting more fire on the ground, like the fire department, turned out to be the total opposite. The fire department gets trained, they love burning, and they're getting good feedback from the public on this. So I want to jump into talking about, we're talking about the limitations And I want to talk about some other experience we've got that is kind of sobering and not, I'd say, super surprising. Simply jump through. I kind of put together a different slideshow in case the video didn't work. So we did a project for, it's funded by the Bureau of Reclamation for the South Lassen Watersheds Group. And we looked at 800,000 acres in the foothills between Chico and Mount Lassen, kind of around Lake Almanor. And the objective here was to prioritize areas for fuel thinning and also for prescribed fire. It's kind of a cross-boundary project. There's a lot of private land. There's not a lot of WUI here. You know, it's kind of Lake Almanor and Westwood are kind of the main WUI. But we wanted to model landscape scale fire behavior. So we used the land fire data set, which is pretty much the kind of nationwide fuels data set that people start with when they don't have better data. We've used land fire a lot over the years, and there's some places that it's pretty good and other places that it's really kind of just garbage. Land fire is kind of a compilation of all the best available data that they could get their hands on. And so that would be vegetation mapping, that'd be Forest Service kind of historic stand structure, just a real hodgepodge. So a lot of fire behavior modeling starts with a vegetation map, and we kind of crosswalk that into surface fuels. And so there's a lot of problems with that approach, but that's kind of, you know, the biggest problem being that, like, you can say it's oak woodland, therefore the surface fuel must be grass, but there might be brush in there. You know, you really have to understand the assumptions that went into creating the initial vegetation map. Like I said before, a lot of the stuff is based on Landsat. So here's a Landsat image that was classified to create canopy cover. And we use canopy cover to look at crown fire potential. We also use what's called canopy bulk density that looks at kind of the relative amount of biomass in this three-dimensional space. Another thing that goes into some of these models like land fire is they update them based on disturbance. So, you know, the original land fire was maybe based on Landsat, and then we've had a lot of fires in the last 15 years in the project area. And those have all been mapped afterwards with satellite imagery looking at before and after. And we say, okay, this is low severity, high severity, moderate severity. So therefore in land fire, then we're going to say high severity is now a brush model for 5 years, or it's a grass model, and then it's going to be brush. Moderate severity is a timber litter model that after 5 years is maybe going to have more dead and down. Low severity, maybe we're just going to say that that's, you know, burns like oak litter, just because we don't have a lot of models to use to represent. So you just kind of grab one and throw in there. And basically your intent is like, we want the fire to slow down when we get to the area that was burned. And we want to slow down differently if the fire burned hot or not as hot. So a lot of kind of coarse landscape scale generalizations go into these data sets. So as part of this modeling, I was telling a little anecdote before everyone was on, just that I was talking to my sister who's a scientist and about modeling. And I said, well, basically what we do is we take the fire and then we tweak the parameters until it moves like the fire we've seen in the past. And she argued that that wasn't legit, and I agree. But that's kind of what we've got to work with. So here's the Ponderosa fire from 2008, 2012. And this fire, it burned about 20,000 acres in the first day. It burned in clear cuts, and a lot of these clear cuts have been planted densely in young conifers, and then they thin those after about 8 to 12 years because there's too many trees. They have to plant it. In the past, they had planted a really high density because of stocking standards. They were a relic of making sure that people didn't just clear cut and leave and not plant enough trees. So we went in the other direction, and we make people plant too many trees, and then they all survive and it becomes a thicket. So that's changing, but for the past 20 years or so, every time someone did a clear cut, they had to plant like 400 trees per acre, which is way too many. And then you have a thicket that burns like crazy. So you have to thin it. And then when you thin it, you just leave all that dead wood in the woods because it's not worth it to haul it anywhere. So this landscape was covered with clear cuts that were full of red slash from recent plantation thinning. The fire ran 20,000 acres in an afternoon. So we wanted to look within our project area. You know, we kind of have to model each kind of ecotype differently. Fires in the red fir elevation above 6,000 feet are going to burn differently than fires in places that are 105 degrees in the summer. So anyway, we ran a kind of what we call linear ignition here, cranked the wind up until it basically spread the same distance as this fire did in the same amount of time. And so that required cranking the wind up to 40 miles an hour, which wasn't what was going on when the fire here burned. This burned and there was like, 5 mile an hour wind or something. So it's just, we don't have that many parameters that we can tweak in these models to make them burn faster or farther. You just have to really crank the wind up. And when that happens, then it isn't, it's not accurate. It doesn't, it really doesn't tell you what's going to happen. Part of the problem with this is that, like I said, the land fire data is based on kind of best available information, and that's a patchwork of what you're getting from the Forest Service versus what you're getting from private timberlands. Maybe the private timberland owners don't want to share any of their stocking information with you because it's proprietary, or because they started a fire and you sued them for $100 million and made them give you a bunch of land. Anyway, this is canopy base height data for the area around Lake Almanor, and as you can see, it changes radically at property lines, and it doesn't in nature, it just does in data sets. So we couldn't really use this at all because it's saying that the meadows where there's no trees have canopy all the way down to the ground, and that's saying some places that are clear cuts have canopy that's 35 feet off the ground. So this is land fire, and anytime if you're scoping a project and someone says they're going to use land fire data to model your project area, then you should run away. So what I did just here is this is a program called IFTDIS, which uses land fire, and it's an online tool that's pretty great for prioritizing areas for fuel treatments. Great concept. Some places it works better than others. So we ran IFTDIS here to do the landscape scale modeling of our project area of 800,000 acres. So I brought that into Google Earth, that IFTDIS mapping. And I want to show you what actually happened with the Dixie Fire. So our model said that areas in green would have surface fire, areas in yellow would have some torching, but that doesn't mean like a ground fire that runs everywhere. It just means that it can get up into the trees that are in clumps, and that the red would be crown fires. So this project got done in spring of 2021, 800,000 acres. And then the Dixie Fire burned like 500,000 acres of our project area. So red areas here are areas that the Dixie Fire basically burned as a crown fire and killed every tree. So I'm just gonna go back here. Our model said there'd be some torching and a lot of surface fire, and Dixie Fire said, no, I'm gonna burn everything. So garbage in, garbage out, right? But also the Dixie Fire is just one of those events that's really changing our understanding of how fire works, right? Climate change, drought, overstocked forests, kind of a short period of record of us looking at how fires burn. Landscape scale changes in fire behavior. And so, I was at a meeting, a forestry meeting recently, and there were some top scientists there who have been writing about this stuff my whole career, people my age. And one of the guys just said, we don't know anything. Like all the stuff we thought we know, we don't know anything about how forest fires work. Angry, upset, hurt, shocked. I grew up right here in Westwood. And so everything within 50 miles of where I grew up in 3 of the 4 cardinal directions got burned last year. And these are places that we've all spent a lot of time thinking about how fire would burn, done a lot of modeling. And it's like, it's nothing, the models are nothing like what actually happened. I was working last year for the California Energy Commission on a project called Pyrogents, which is an attempt to build some good real-time models that we can use to plan things like public safety power shutoffs. but they're all based on land fire. They're all based on the weather data that we use for this. They're based on an old understanding of the climate. They're based on an old understanding of how fires behave. They're based on an old understanding of forest dynamics. All this stuff has just been patched together, over years by different scientists who had kind of creative ideas. So like our canopy models are based on tools that were developed when we were still doing major clear cuts in the Pacific Northwest, where we needed to estimate how much slash would be on the ground after we clear cut 100 acres of old growth. And so they would take some trees and they would kind of dissect them and count the slash from the different strata of the trees. Those equations are still being used to kind of translate and build our canopy bulk density. So I think like all modeling, it's this real hodgepodge, and you have to dig really deep to figure out how the model got built. It's like trying to maybe understand one of these big climate models that's 450,000 lines of code built by 10 different laboratories at 10 different universities over the last 30 years. There's a lot of little kind of on-off switches built in where, oh, that didn't work, so let's make sure that like we run this to keep that from happening. Just that's kind of the DNA of our major fire spread models. So we've got, the good news is that we've got no shortage of data now to critique them. The bad news is just that the fundamental science of fire spread is not well understood. And our best and brightest brains don't, I don't see a lot coming down the pipe that's going to help us get better at modeling catastrophic events under extreme conditions, especially in the urban interface. So, that's why we used it the way we did in the city of Chico. It's just like, okay, well, the models are good at showing us where you have continuous vegetation. They're good at showing us where vegetation, at showing us the transition from surface fire to canopy fire. And we know that any fire that's torching is a problem for firefighters because it's going to spot and they'll be spotting behind them where they can't see it. We call that problem fire behavior. So, it's not like this stuff is useless, but it is useless for predicting these extreme events. It might be helpful here in Chester to tell you where you might want to thin the forest, but one of the big takeaways also from the Dixie fire is just that this area here where the fire burned, a lot of it had been really well thinned over the past 30 years. Around Westwood, you can see like the forest changes color in its imagery. Part of it's just that there's different lines of imagery here. But you can see, you can see that this land has all been thinned. We had a biomass power plant in Westwood for about 25 years, and they thinned all the flat land within 50 miles pretty heavily. So there are some places that brought us advantages, but when we look around Chester, Collins Pine Company has been held up as kind of the gold standard for sustainable forestry in California for a long time. And they had a lot of forest that was fairly well thinned. And they lost 50% of their forest in about 2 days. So just a lot of these assumptions we've made in the past about vegetation management and how it's going to affect fire behavior, fire severity, they're kind of out the window. All right. So that kind of, I guess I can take some questions. That's kind of the visuals and some of the background.
Okay, we have a lot of questions, Zeke. So, I mean, I'm not surprised at all that what you're taking away from your experience in fuel modeling is that it's not accurate. Because my experience with fuel models, where areas where I've done a fuel model and then the area has just coincidentally burned, is almost the opposite effect. And my fear is that these communities, these large landowners, they're buying into the fuel models, and I understand that it's important. We, in this time, in communities, we look to our computers for the answers.
Right.
And I did not know that the models were all created in the 70s. I thought there was always a continuing development of these fuel models, because we've been asking, the fire agencies have been asking for a long time, hey, how does the model interpret, say, a beetle infestation or a large, in San Mateo County, we have a lot of SOD kill in some of our deep ravines that are unaccessible. And we know that changes fire behavior. We call them hot spots. The biggest question to me is when you build a 3,000 square foot subdivision, where houses that are 3,000 square foot and they're all wood, how does that change the model? I mean, it's.
Well, I think, yeah, the thing that comes to mind, I spent the winter of the campfire, working in the campfire burn in the ruins of Paradise, driving around. We were working on erosion control projects and kind of toxic runoff mitigation. But what struck me there was that you didn't see a lot of old ratty houses standing because they all burned down. What you saw were well-maintained houses that had tight eaves and well-maintained. Just, it's surprising. I mean, there were places where there was vegetation right up against the house and it would have survived. But what we've taken away from that is just that you have to keep fire from getting in the neighborhood at all, because once houses are on fire and firefighters aren't there because they're evacuating people and saving lives, it's unstoppable. And so how do you kind of really find those places on the boundary of the town where you can stop that per structure from catching on fire?
No, that's a really, really, really good point. So let's start up our questions from our members. So Dale is in Portola Valley, and I'm not sure if you're familiar with NIST and their experiments and their fire days that they're conducting right now. They're doing the experiments on structure separation. Anyway, that's happening right now. So and they've done some already, and their information is out there, and we can send that to you. So his question is, how does this take the latest NIST structure studies into account? And I think you're going to say doesn't.
The stuff I'm doing doesn't. Yeah, we weren't really, that wasn't really our objective with the City of Chico plan. It was more of where do we manage vegetation to keep fire from getting in neighborhoods at all.
So what is your take on structure separation? I mean,
well, I helped out. I took Eric Knapp and Jan Valakovic up to the campfire pretty early on after it burned, and then they wrote a paper about it, and they found that the structure separation was really the critical element in determining whether or not structures survive. So I guess one of my takeaways on that is that even your wood or your little storage shed has to be built to a WUI standard because the fire doesn't care really if it's your garage or your chicken coop or anything else that's on fire. It just knows that there's this major source of radiant heat right near your house, and then your house is likely to go. And so we're stuck with this kind of, I think a lot about Marin County and fuel reduction, and it's like when the fuels are houses, we're not going to reduce fuels. We're not going to thin houses. We're not going to tear down people's garages. And so there's these limits to vegetation management because they're not, oftentimes the vegetation isn't the key fact. Vegetation wasn't what took out the neighborhood Coffee Park and Tubbs fire. And vegetation really in Paradise wasn't necessarily the thing that took out Paradise.
you're saying it was the structures. I mean, we know it was a wind event that helped spread the fire, but when it got to the City of Paradise, what NIST and all that study told us is that once it got to the city limits of Paradise and into the structures, the wind event was over. And then it was kind of a structure to structure ignition.
Yeah, and it burned as 20,000 different fires. Once it was in the neighborhood, it was like little. The problem with like a wind event like the campfire is that even if you just raked all your pine needles and leaves, it was a time of year when there was still a lot of dead leaves on the oaks and a lot of dead pine needles. And the wind event blew all that stuff down again. And so you might have had a perfectly clean yard the day before the campfire, and then you would have
Right.
leaves all over the place. And those
Good
leaves
point.
and pine needles, they eddy out in the same place behind your house that the embers are going to. And so the radiant heat in the neighborhoods took out a lot of fires, but there were a lot of houses in Paradise that were on large lots. You know, my coworker had a 2-acre lot with nothing, no structures near it. He lost his home just because of there was no one fighting these. You know, if you had a bunch of people there with, you know, fist pumps and rakes, they probably could have saved hundreds of homes, just because the fires that were spreading from structure to structure were just these slow moving surface fires a lot of the time, starting from embers and dry oak leaves.
Right, right. And I think a lot of the houses in Paradise were kind of older, so there wasn't a lot of ignition resistant construction.
Yeah, though 50% of the homes that were built with the new construction standards also burned.
Well, I think they're doing a revamp on that, so you know, 7A is a start, but it has a long, long, long way to go. And I think we'll see a revamp in the next in the next year or so. So Jennifer has a question, and I think this is more pertains more to kind of maybe your county and other counties in the foothills. Is part of the problem with predicting fire behavior due to the transformation of our mature biodiverse forest into unnatural timber industry tree farms? Kind of what you described with that scenario.
Yeah, I think no one's got good resilient forests, right? The Forest Service doesn't, private industry doesn't. We've changed it so much, but one of the key factors in Collins Pine losing all their land, you know, 50% of their acreage in that short time period, is just that their landscape was covered with trees that were under 70 feet tall, and therefore just not resilient to, there's more prone to torching and browning. So yeah, the change of the landscape scale changes and forest cover don't help, but you know, the climate and drought and stress, the beetle stress, everything that's across the board, kind of regardless of ownership or management strategy.
Okay, Nikki Hansen has it's a long question, so I'm not going to read it. I'm going to ask her to unmute and to actually ask her question. If you could,
Yeah,
Nikki.
Yeah, let me open the chat too.
No problem. Let me do that too. Sorry. Okay. Yeah, I guess my question is kind of putting everything together and looking about how you take all of this information and synthesize it into acting on fuel reduction projects, and kind of where you focus your efforts and where you prioritize your efforts. As I listen to more and more of these talks and just gain more information, I think my takeaway starts becoming that we should just focus increasingly on edges and sort of edge zones. And that could mean, you know, upping the maintenance schedule along roadways, so it's just really on it and really tidy, meaning increasing the amount of mowing and limbing up of trees and just, you know, general maintenance. Also increase, like upping the ante on just how much we're doing on our home hardening and our defensible space. But then more than that, even just the edge zones around a town altogether, those transition areas, or even like within the landscape where you prioritize your efforts, in my mind. For example, on a small scale, when I look at our family's rural 40 acres, which has meadows and oak woodlands and then conifer areas, my strategy tends to be focusing on kind of reworking and defining those different habitat types and having those transition zones be really tidy, so that hopefully if a fire was passing through the landscape, it would have a chance to kind of not just go straight from the grassland, climb right up through the brush, right into the canopy. So kind of redefining all those edge zones and doing shaded, thinking like, oh, shaded fuel break around my meadow edges, and then, you know, mowing or maybe controlled burns or something in the meadows. So it's like redefining those edges so it's not so homogeneous and has this more continuous fuel structure. And I guess I'm just like more and more thinking like, edges? Do we just focus on all these and
Yeah, I
edges.
think the problem is there's a lot of edge, but
There's so many.
but I think, definitely we talk about problem fire behavior and spotting. It's like in these places where we expect to have a wind-driven grass fire burning towards a neighborhood, it's like, yeah, let's do everything we can to keep it from torching and spotting. Because when we're getting long-range spotting or even medium-range spotting, it's really tough for us to really pick it up. And especially if, like in Paradise, just all of our firefighters were busy saving people's lives and not fighting the fire. And maybe your aircraft are going to be focused on dropping along roads so people don't burn to death in their cars. So I think it is really important to focus on that, preventing torching and identifying those places, those transition zones, and focusing on that. It's like, okay, let's make sure that if we've got, roadside clearance project in this area where we expect the big north wind fire to, when we model it, it's like, well, can we look at places where we have high ignition probability and expect a fire to grow large quickly because of the fuels? And then what can we do? I think it is important to kind of be modeling specific scenarios that have been identified by your local old timers and say like, hey, we're really worried about a fire starting off of Woodside Road at this intersection with a north wind. Because we've got so much landscape to treat that we really have to triage that. I mean, coming back to your talk about edges is, around the edge of Chico, I think we really need to burn a lot. It meets our rangeland management objectives. It meets our, it helps our fire department is really happy when they've got some black to work with. And so if you can look at places, and you can do the same thing with goats, it's just more expensive. But I think, we need to be strategic about this. Can we graze this 10 acres with goats and then have an easier time burning this 100 acres later in the season when we need to do it for star thistle? Like we burned last year for star thistle, we burned a little too early, we decided. So this year we wanted to burn, but then it was not too late. We start sending people out of county on, wildfire assignments. But if we were able to graze the margin of that, then we could burn in July, we could burn in August. So thinking strategically about that, but the projects need to be large. We can't, we're not going to get anywhere with like a 5-acre prescribed burn. Like we need 100 acres or 400 acres. And then you have to do it every year because we're talking about annual grasses being the issue. So how do you restore your grasslands to, in places where they're encroached by invasives or by conifers? You do meet some objectives there by removing that encroachment, you remove torching. If you got thickets of Doug fir around your oak woodland. So I think a lot of what we call fuel reduction over the last 30 years, we could have probably branded it as like oak woodland restoration or habitat enhancement, and then met these multiple objectives.
I think
So-
that's another thing I just noticed, just to one last thought, and I'm sorry I'm taking up time, but I think we would get so much further if we combined the habitat restoration mindset, fuel reduction mindset and efforts, invasive species control and efforts. Like there's a lot of overlap here, firefighting, and I just think that is another issue I see where there's still gaps. And if we combine this, we'd actually be making more progress faster, better, kind of having a more holistic approach. Anyway, thank you so much, Zeke, for your thoughts.
So Nikki, just a comment on that. Actually, Jasper Ridge is trying to do that. And they're having a very hard time of it. And they're some of the brightest scientists around, but you might want to follow what they're trying to do. So they're trying to put, fuels, hazardous fuels management, ecology, the environment, the native species, the habitat, all into one pot and do exactly the right thing. And they're finding that it's extremely, extremely difficult. And they just produced a white paper, or at least it's on a draft. So I'll hook you up with Jasper Ridge,
Okay.
and you can follow what they're doing there. So
Yeah,
you have
and I
a
realized,
local
yeah,
entity.
that would be awesome. I would love to see that. And I think what I'm saying is not necessarily hitting every single topic at once, but I just see there's often a case where if you timed the mowing, for example, to be when the 10% of the thistles were blooming instead of when everything is seeded, you would be making your problem easier each year instead of harder each year. And that would have been incorporating in that, hey, how do we decrease these invasive thistles? Plus, how are we making this roadside more fire safe? So kind of just more hitting on a couple points, even if we're not doing absolutely everything. Like, hey, we are going to take down some of these.
Yeah, killing two birds with one stone. Yeah, exactly. That's
just
always
a little bit more. I think is even if you can't get everything, just even saying how many things can we overlap
right.
with a little tweaking.
Yeah, and
I'm all for it.
yeah, that's one of those places that GIS really shines, is getting everyone's information in a common place.
Yeah, Nikki, that would be great to talk to you. My hat now I'm at Jasper Ridge. And so it would be nice to talk to you about that. But those are great thoughts. Thanks, Denise.
Okay, so Zeke, Michael Barber, and he's from the county supervisor's office. So he has a really good question about historical fire mapping. So we know that there's historical fires all over California. They're fairly big fires. Maybe they're 50, maybe they're 60 years ago, and they don't have a lot of damage because there weren't a lot of structures there, but their footprint is still there. And then we build in these areas, and then we have these fires are repeated. And we already had the data. We knew that these areas were potentially fire prone, and the footprint was, already there, and potentially could be mimicked. What's your take on that? How should we be looking at historical fire footprints?
Well, there's sure a lot of them, right? Like,
Yeah.
here's my area. Kind of redder and pinker colors are going back more to like before the 60s. Blue is kind of newer. But yeah, when you look at like Lake County, like there's plenty. And I guess what I think of a lot with historic fires is that fire is kind of a great storyteller, and fire tells you what it likes to do. It tells you, we talk a lot about alignment and how when the weather and fuels and topography align, you've got things happen, right? And so like different parts of the landscape have different alignment. So here around, the east side of the Alaska National Forest, fires run from the southwest to the northeast. And you look across the landscape and it's like, that's the story. It's like fire starts with prevailing wind and it runs, and we start at the heel and we march up the flanks, and eventually like sun goes down and we put the head out. Or it starts along a highway and it runs to the top of the ridge, and because we're in California, we've got 15 hotshot crews there by midnight, and we pick it up the ridge. And so like the whole landscape, the fire tells us like, I've been here before, but it also tells us I was here and this is what I did. And so one thing that strikes me, say in Plumas County, is that, hey, we know that we have fires that once they escape initial attack, they go to the ridge. So maybe let's not build any towns up here, right? Too late for Greenhorn Ranch, like they're already there. And now every time there's a fire, anywhere within 10 miles, we have to evacuate these people and they have to live in fear all summer. And so, I mean, we wrote a fuels plan for Plumas County, and that was one thing we said, is like, hey, you really need to prioritize spending downslope of communities that have, a history of upslope fires burning from the southwest to the northeast. So part of that is just like, hey, let's not make the problem worse. But another part of it is like, okay, for the modeling, it's helpful because I can say, hey, I need to tweak this model until it hits the ridge in the first day, because that's what fires have always done around here. So like the fly fire that happened during the Dixie fire this year, it pretty much did exactly what the landscape has been telling us the fires have always done here. Start at the bottom of the hill, hit the ridge by the first night. So it is helpful. It's a little hard to parse a lot of that apart because of suppression. And so we don't really know what fires really want to do around here. We know what they do when you've got 8 air tankers hitting them and 4 dozers pushing within an hour. But it definitely gives you, it definitely is that easy storytelling tool for the richness of fire on the landscape or the deficit, right? So then we get down to your neighborhood and it's like, man, how come it doesn't look like the rest of the state? Like, what is it about your area that has no significant recorded fire history? Is it a function of your weather? Is it a function of your population density? Is it a function of your suppression effectiveness? And then what about climate change is going to change that? Are we going to have more east winds? Yeah, so is that helpful?
Yeah, no, I think that's a good point that these historical fires, they're going to be in our future. I mean, the same footprint, and it seems like some of them, when they repeat themselves, they're bigger. I'm not sure if that's kind of the takeaway. They're not smaller when they repeat, because now we've built houses in there. So we're kind of creating the problem. We're making the monster bigger. And I don't think there's that's probably not going to change, but I think you can plan on having the same fires, but on a larger scale as we build out the environment.
Well, I think the thing to keep in mind a lot too with these polygons is like, we like to think in these kind of solid shapes. But then like when I was showing you the Dixie fire earlier, like fire is messy and the severity is all over the place. And so even though you see a solid shape on the map, the ecological effect is anything but solid. This is all this area here that's drawing is all solid color in the fire history map now. It's like Dixie fire burned this entire area. But when you zoom in, it's like, well, some of it, burned at night. Some of it burned when there's heavy cloud cover. It burned over the course of months. And during that time, we had all kinds of different weather and wind and fuel and moisture. And so it's complicated, I think, when you start portraying these really kind of heterogeneous events with solid colors. So another question that was about air quality and whether or not our local air quality district is supportive of prescribed burning around Chico. And there's kind of a cool story there that originally she was not. Her job was to absolutely keep the air clean as much as possible and make sure that rice farmers could burn their allotted pollution on the days that they were, and just kind of wrangling rice burning and stuff like that. And then Don Hinkins, who's a professor here at Chico State, native California burner, he travels a lot to Australia to burn with Aboriginal people. And so he took our air quality regulator down to Northern Australia, I think, and they burned for 3 weeks. And now we get our permits whenever she can, because we showed her that it was an incredible tool for land management, and she's come to understand that the wildfire smoke impacts are an order of magnitude greater than prescribed fire impacts, and that we can really manage the smoke. When we burn the park, we have a prescription for smoke management. So smoke management planning has come a long way. We've got a lot better tools for it. You guys are still in a really tough position there, just because your regulators have so much to balance and such high population density. But I feel like air quality has been a convenient excuse for years for people not to burn. And in some places that's been valid. Other places there's kind of this imagined tension, I think, between prescribed burning and air quality. But you guys definitely have it tougher there than we do here.
Well, and you've studied San Mateo County a little bit. I mean, do you have areas that you that stick out to you like, hey, that would be a really good area to burn? Because as a retired fire marshal, it was really hard to say, well, geez, you got so many houses here. We're burning so close to the houses, is potentially is risky business. We just don't have those 100-acre swaths. I mean, there's parks, obviously, which is possible. There's mid-pen open space, which obviously is possible. There's part of the watershed, but those are some of those the watershed is fairly far away from homes. The parks and mid-pen property, open space land is much closer. So I'm wondering, being a map guy and, and understand the geography, are there some areas that potentially pop out to you?
Well, I know that Mid-Penn hired Phil Dye and Sig and some other of my big brain friends to be looking at that. And so I, personally, I can't really speak to the specific geography of that. I think, you're right in that burning a lot of these more rural areas might not really buy you a lot in wood protection. I think the thing that I come back to a lot is just that the ecology is not going to be destroyed by a fire here, or just about anywhere in California. I've been driving around and stuff that is really high severity fire around here, and it sucks to see it. Sucks to see that it's not timber anymore, but it's like there's 8-foot tall black oak and chamise, and like the landscape is not destroyed around here, even by these really high severity fires. So definitely your picture is like, yeah, how do we protect our communities? But I think that protecting the ecology from fire is kind of like not a big concern of mine. You're gonna have fires, even high severity fires, and 3 years later, most people who drive through a lot of these areas won't even know it happened. With the PBAs, prescribed burn associations, we are burning right in people's yards here in Forest Ranch, in Pine and Black Oak, in the Klamath Mountains. We're burning right in people's yards, but it is a question of what bang for your buck are you getting? I think that it doesn't have to be as complex as people make it, but you're in such a unique kind of geography of wealth and privilege and 5-hour planning calls. Like your social, yeah, your social fabric is so different from most places I work that I don't really know what to say about burning where you are, except that I would love to be part of it if we can happen, but I'm not going to sit in 100 hours of planning meetings to burn 100 acres either. These big chunks like Jasper Ridge, there's some opportunities there to do low complexity work. I think if anything, the reason to burn is to help people be less terrified of fire and help them understand all the different ways that it works on the landscape. But I think I've been doing a little work in Portola Valley on the general plan update, and just really more than anything, we just did a really kind of like high level kind of overview of the issues. We didn't really get down to specific project locations. But this whole idea of fuel breaks, like, hey, let's put a fuel break along the edge of this preserve. Like, I think that's kind of old thinking. Like, that's stuff that we were doing in the 1930s, and especially in the 1990s. And it's not really changing the outcome of our major fires. It's just this disruptive kind of entry that you have to maintain all the time, and it kind of assumes that you're going to have fire suppression resources available when the big one comes, and you won't. So that's probably better money spent on home hardening. That doesn't mean, like, coming back to our talk about edges, that doesn't mean that you shouldn't target defensible space aggressively along all this margin, but I'm just saying that it probably doesn't mean that you need to like clear a 100-foot wide swath here and keep it bladed with a dozer every year and think that somehow that's going to keep the big one from coming into town.
No, you make a lot of sense. You either have to go big or go home. And we're seeing some of that, some of our fuel breaks that we've done over the years where we just, reduce the fuel. I mean, maybe we have an area, we had 20 acres burn a few weeks ago here in San Mateo County. And I think it might be neat to do fuel modeling because we have the LiDAR from before the fire, do the fuel model and actually show people this is what the fuel model said it was going to do. This is what the fire actually did. We actually had some fuel modification about 3 years ago and about 10 years ago. So kind of show the history of all this planning and what you're saying, all this money and time and expense. What did it actually get you? Did it do the job? Is this what you want to be spending your time and money on? Are you happy with the historical actions that have happened?
Yeah.
And I think putting all that info together is important for the community.
Well, I think the utility fuel breaks, like, they're not useless for sure. It's just that we're seeing that they create opportunities for tactical engagement on large fires. But unless you know they're there, and unless you have the resources to mobilize an operation based around them, they often just kind of get spotted over, and, you know, especially in timber. And so you have to be thinking of specific scenario and say, you know, one thing that was really striking in Paradise is, like, if you look at the kind of productivity of the brush there, it's one of the best places in the world to grow conifers. Like, I saw a stump up there from a tree that was 50 years old, and it was like 42 inches at the stump. And the lots that had no clearance at all were incredible, just death trap thickets. But everyone did a little bit of work, like 10,000 parcels, and like everyone did a little work. And that made a huge cumulative difference. And that made the difference between 85 people dying and 1,000. And the work that people did, especially on roadside clearance, was critical in helping people not die in their cars. So when I think of, you know, the San Mateo landscape, it's like roadside clearance has to be a really, really high priority, because that's where people die, is in their cars. And we know the amount of people that are packed in here. You know, this work we're doing with the general plan update in Portola Valley, people are worried that if we add more housing, that it's more likely that we'll have traffic jams when the big one comes. Like, we're going to have traffic jams when the big one comes, whether you have 200 more people or not. It's just a function of people waiting too long to get out, and the fire moving quickly, and really limited ways in and out for thousands of people. So whether or not you're going to build new houses, like, let's push out these right of ways as aggressively as you can on these routes that we already know are going to have traffic problems. And then if we can push out from those, but, you know, we really have to start with, like, when we talk about maximizing the impact of our work, we really have to be looking at that. You know, that roadside clearance pays off when we have a big fire. It's like individual structures, maybe it helps, maybe it doesn't. But as far as like saving the lives of thousands of people, we really have to focus on these known high value corridors.
Yeah.
And that's something that modeling really can't tell you, you know. It can show you where you've got thickets along the road, maybe you should then, but it can't really, I don't see it really being that useful for modeling a scenario where a fire like starts here and runs up here. Like, how is that going to affect the neighborhood? It's like, we already know, looking at this, that like if a fire starts down here at the bottom of this road, it's going to burn to the top of the drainage. If there's any, you know, like, you don't need a model to tell you that.
Hey, Denise,
Yeah,
I don't know, is
Yeah, go ahead, Michael.
Zeke, thanks. This is a great presentation. Denise, if we could clip that part that he just talked about with the fires, the roadside clearance, and
Well, yeah.
send that over to our DPW roads crew. I just wanted to, Zeke, thanks for doing this. I'm a big fan of yours. I follow you all the time on these, and the presentations you do are great. The issue that, and you touched on it, is we talk for hours down here, but we don't get a lot done. You know, how do we break some of the regulatory barriers, and also how do we get through to some of the private landholders? I mean, down in our case, we have SFPUC owns a huge chunk of property, which is way overgrown, has not had any major fires in decades, if not 100 years. So I'm curious, how do you work with the private landholders, regardless of who they are?
Well, you gotta,
and just sort of getting through the regulatory barriers.
Yeah.
You touched on the
Well,
air quality one, and that's great.
I think, you know, one of the big things, like, people like to hold up CEQA as being the obstacle to getting projects done. And CEQA doesn't apply if you're not using public money. And we have laws that say you have to clear around your structure, and they're not being enforced. No, the firefighters don't want to be cops. And so we've got 4291 that says you have to have clearance in unincorporated areas. You've got state weed abatement ordinances that give the cities the same authority, but people aren't enforcing these laws. And you've got plenty of people with money that can afford to hire a contractor to clear, to comply with the law on their private property. And part of it is just enforcing the law. And I think the insurance companies are like the only people that really have any leverage to make that happen now. And so I think working with insurance companies to make sure that, like, insurance companies want to write policies. They don't want to take losses, but regulation of existing, like, we don't need new laws that tell people they have to cut brush around their homes, but we have to enforce the ones we have. As far as public funding, as far as public funding and CEQA, there's so much, I think there's a lot of room in the categorical exemptions. Part of it is just cultivating. We have so much turnover in CAL FIRE and these other agencies that by the time someone figures out how CEQA works and how they can actually just get through it, they promote somewhere else. And so part of it is just not letting CEQA be an obstacle and pushing as hard as you can on using exemptions.
No, I think you have your finger exactly on the pulse of the problem. We have the laws on the books and they're just not being enforced. Same thing with, it always, we have these evacuation routes and everybody's worried about evacuation, but these rights of way don't belong to the residents in terms, I mean, there's restrictions, but the cities and the counties allow people to fill in the right of way, our evacuation zones, and then plant trees underneath the power lines, and then we blame PG&E when, branches fall on the power lines. PG&E didn't go around planting all these trees. It's the residents that did this. And
Denise, can I ask a question?
Yeah, go ahead.
Okay, thank you. So I'm curious to get your feedback on the LiDAR technologies. Obviously, we're seeing, as you pointed out, that there are limitations, that it's difficult to come up with an accurate predictive analytics. I do know that there's a lot of new technology expansions and developments in the LiDAR field. That LiDAR is being expanded into other types of applications, security, and putting them in airports and things of that sort. A couple questions. One is, what do you see as potential improvements in the near term in which LiDAR could be more helpful in the predictive analytics? And also, how often would you feel that a community needs to do LiDAR mapping? It sounds to me like because of the constant changes, and if you have a fire or something, obviously you got to go over again and redo this. So I'm just curious as to what levels of mapping should be done, aerial mapping on this.
The LiDAR is great. The higher point density now is helping us see kind of deeper into the canopy and get a better idea of the surface fuels and the, well, not as much surface fuels, but the lower canopy, like crown base height. And so it's a huge advance from what we've had in the past. I think the problem is just that the models really aren't able to, it's great for some project, like identifying project areas. It's less great for spread modeling, just because we're still limited by the same technology with the actual models themselves. But I think LiDAR is a great project planning tool. On a refresh cycle, it's hard for me to know. I think if you have LiDAR and it shows you've got tickets and you go out and do a project, then hopefully you track that project and you don't. You can go back and look on the ground. So I think you're going to just end up having a lot of LiDAR just based on your location and the amount of interest in assets and infrastructure and everything else that it's helpful for. Where we work is like, if we can get LiDAR at all, we're happy, and we don't care if it's 5 years old because it's way better than anything else we have.
But ideally, should it be done like every couple of years? Or I mean, do you have a thought on what the frequency might be?
I think it's going to get more accessible, that the drone platforms are going to be cheaper, and it's going to, the barriers, the cost of acquisition is going to come way down, I think. And so if you can do LiDAR on a 1,000-acre piece, like a park or a neighborhood or a subdivision, right now there's kind of a minimum order. If you're going to hire someone to come in with a high-flying business jet with $1 million sensor, like they don't want to turn a prop for $125,000. But I think that's going to be the main thing that changes, is that it's going to get easier to do smaller acquisitions, and that you don't necessarily need to fly your whole county. You can use your countywide data to kind of triage your landscape and identify places that you want to focus in greater detail. But that's always kind of our approach with modeling, is we start out with the whole county. We drill down to the higher priority areas, and then we go out and look at those on foot, or we, look at air photos. You don't have to do the entire landscape, because there's parts of the landscape that you're not worried about with wildland fire.
Yeah, that's a great plan. I mean, I'm assuming San Mateo County Parks and Mid-Penn could, in a few years, redo the LiDAR. It would be a very important tool. They have a base map now, and there'll be a few fires from now to then, and they should just put that in their operating budget. Talking about Mid-Penn, Craig Beckman from Mid-Penn has a question. So as you know, Mid-Penn has a lot of land right up against the WUI. And so, Craig, go ahead and unmute yourself and just go ahead and ask your question. He wants to ask a question about perimeters and areas like sudden oak death and hotspot areas like that.
Yeah, thanks, Denise. I've had a handful of questions relatively recently about sudden oak death, and some of the places people are asking about seem to me to be pretty remote, quite a ways away from any homes, and really impractical to remove any of that material. So I'm trying to understand if it's, when might it be a priority to go into an area of dead trees, and if all you can do is put them on the ground and maybe pile burning, and not that, I'm not even sure how much I can do on a large scale sudden oak death, dead, few acres. I'd probably just leave them there, leave them standing. Or would it be worth going in and taking down trees around the edge of a few acres? Would that help? Or the fire would still get into the center of that dead zone? So for me, so far as a priority, unless the sudden oak death is close to homes or close to escape routes, it hasn't been a priority to go deeper into the forest to manage dead trees. So just trying to get a sense of why that might be a priority and where.
Yeah, I don't see a benefit in putting them on the ground. I think it's, there's so much, the scale of the fuels problem is so immense that we really have to triage and work close to structures.
Now, when you talk close to structures, Craig's definition of close to structures and your definition might be different. Can you tell us your definition?
Yeah, like as far as you can throw a pine cone.
Okay, so 100 feet, maybe, for me, maybe.
I can't throw very well either, so it's fairly conservative
That
metric.
should be a contest we have.
Yeah, well, I can throw far if it's downhill and it rolls.
Yeah, well, and that's a good point. Like, you might have a rolling pine cone burning,
Right,
rolling down to
right.
your house. So
right.
I appreciate that, Dennis. Denise, I would have said, my number probably would be less than his, but in this case, I think I would be willing to go farther than 100 feet when there's a significant grove of dead trees.
Sure. Well, yeah, it comes back to what we were talking about with scenarios, and obviously, I worry more about kind of spots from, like, if we just dump a bunch of dead trees on the ground and have a big jackpot pile there, which one is more likely to give us spots? Because coming back to that idea is just that we really need to reduce torching potential in areas that are kind of close to critical control places.
Yeah, thank you. I'm sure that's not the final answer, but it's good to hear different points of view. Thanks.
Okay, it's getting to be around 11 o'clock. Is there anybody who has a dire question that you would like to ask before we start to wrap up? I mean, modeling is a big question, and I'm sure this won't be our last presentation on modeling. But I think, as we've heard today, that there's a lot of downfalls currently because the models that we're using are so old and, really antiquated. I mean, I don't know if somebody did a model, Zeke, and you say, okay, well, that's the That's the flame map model. Should we just multiply it by 3 and say, well, we know the model is probably inadequate, so let's just double it or triple it in terms of rate of spread, intensity, flame length? I mean, how should we start using these models? Because what my biggest fear is that you do the model and it's, you know, it shows it's not right. And the model is less intense. The rate of spread is everything is less than we told the public. And to me, I would rather say it's going to be worse than it really is, because potentially you save lives that way. And I think the other way around, people say, oh, look, it's not going to be that bad. And I've heard that before. Oh, look, you know, the fire crews will have it out. It's only going to be 4-foot flame lengths. Rate of spread is going to be, you know, 3 acres an hour. They can handle that.
There's so many complicating factors with, because your scenario that you have to kind of build is that on the day that you have a bad fire, like there's going to be fires from Ukiah to San Luis Obispo, and we don't have that many airplanes, you know, we don't have that many heavy helicopters. And that's really like when you look at the Tubbs fire, when you look at the Camp Fire, Woolsey fire, any of our big conflagrations, it just isn't very long at all before you don't have, we're used to dealing with wildfires kind of as a one-off. And we get used to, like, I'm going to go on an initial attack and I'm going to have 3 helicopters and 3 air tankers there within 20 minutes. And then when you don't, then like it all goes out the window. And so, you know, the 2020 LNU complex fires, I was talking to a friend who was a battalion chief over there. Like, yeah, like I had 1 dozer and my 1 engine from my battalion was available, and we just, no one was telling us what to do. We just kind of went out and fought fire on like 12 miles of ridge line. So I think recognizing the limits of our ability to manage disasters is an important part of it. You know, the modeling is great for saying we should do a project here versus over there, but it falls apart under kind of, you can't really model a catastrophe. You can use the tools to tell some stories to hopefully help people understand that.
Yeah, I think you're right. Disasters are always the worst case scenario. And so we have to plan for the worst case scenario. And I think, you know, it's kind of like cleaning your house. You know, you have to do it all the way if you want a clean house, so to speak. And we're trying to promote defensible space around structures. You make a really good point that the laws are already on the books. Let's just enforce them. And how this county does that might be different for each city or town, but I think in any fire management plan, enforcement, really, it should be in like chapter 2, like what is already on the books and how do we enforce what we have? Because enforcement, like you said, your analogy that, you know, doing a little bit of work, but on a large scale went a long way, or it goes a long way.
It had a massive
right.
community-wide benefit.
Right. And, you know, it's funny because we have some really great experts, you know, CAL FIRE and a lot of the local fire agencies are really great. They know the area. They have a lot of historical information. They know what's going to burn. They know the severity. And I think we should try to use some of those experts in what you talked about was the ground sleuthing. You really have to get out there and do the ground sleuthing, not just look at the model from the computer and then try to plan your community around that. So I think, you know, using, you know, foresters and then some of the local experts to help, and then people like you to help us understand the mapping and really see it visually, because a lot of people are visual. I think that's important. So pulling that all together and then some sort of disclosure, you know, about the mapping that, hey, this is just an estimate. You know what I mean? It's not necessarily the full scale of any wildfire event.
Yeah, well, I think it's easy to kind of get into this mind frame of kind of relative hazard. And one thing we learned kind of the hard way in planning, so we did a CWPP for Yuba County, and it was the Yuba County foothills, 5 fire protection districts. And some of it was just the worst conditions you can imagine, with 20-foot tall needle cast brush, with trailers in it, and one way, everyone on a long mid-slope one-way driveway, and just nightmare stuff. And so then down in the foothills there was like oak woodland and grass and a whole community that in contrast was like great. You know, people had horses and they had goats, and you look at it and you're like, oh, like compared to up the hill, these people are great. So we said that area was moderate hazard. And then we had the 2017 fires, the wind complex, at the same time Tubbs was burning, and it burned like 1,500 homes or something. 4 people died. And so what we learned from that is like, don't ever call anything moderate in California. Just because it's not terrible doesn't mean that it's good or anything close to good.
Yeah, well, look what happened in Colorado too. You know, I'm sure they were probably less than moderate, right?
Right.
Mapping. Yeah, well, it'll be interesting to see what the state fire maps come out in both the LRA and the SRA. I think we're all on pins and needles about that. You know what I mean? And CAL FIRE is probably having that exact conversation. You know, how can we call anything, you know, high when everything potentially is very high?
Yeah, it's kind of, yeah, and then just the political pressure on there to not call things very high because important people in power want to still have insurance on their home.
Right. Yeah. Okay, well, Casey, are there any more questions or anybody who wants the final question? Otherwise, we'll thank Zeke and everybody. We did put your website into the chat, and just to plug the Lookout, it is a great website, and Michael Barber commented on that as well. And I think your site, it's not federally or state funded, so you run it all on donations, right, Zeke? So
Yep, Lookout,
yeah, so
crowdfunded.
So
and today I'm talking today on behalf of Deer Creek, not the Lookout. Deer Creek's my full-time job. I'm the director there, and we do GIS and pre-fire planning.
right. So if anybody's looking for, you have a project and you need consultants, Zeke, are you taking new work?
We are.
Yeah. Okay.
Cool. Hey,
So
Denise,
yes,
there
Casey.
was like a procedural question or two about fire safe and the IO groups.
Oh, okay. Well, we can let Zeke go, and we can do that. Okay, Zeke, we want to thank you again, and anybody who needs a great mapper, wildfire modeler, Zeke's available, and check out the Lookout, and if you can, make a donation. So Zeke, we want to thank you so much for spending your morning with us. It's really been informative.
Thanks for the good questions, and good luck. And we're going to be doing a prescribed fire training exchange up here in Butte County in the fall. So if any of you do want to come out and see grassland burning around Chico, reach out to me, Zeke at deercreekresources.com.
Thanks for that. Pending the parks might take you up on that.
Great.
Thanks, Zeke. Great job.
See y'all.
Thank you, sir.
All right. So Casey, did you want to go over something on the IO group?
Well, yeah, there was just a little discussion on the side in the chat about ways to contact knowledgeable people about final reports for fires in the area. You know, how do you find out if there was ever a final report? Say on the one here in my backyard in Belmont, in the San Juan Canyon. You know, how do members of Fire Safe do that? Is there like a private address for in the fire safe community they can send those questions without bugging everybody on the list? Or
well, they could probably send it to me. Are they talking about like a cause and origin? Yeah. So
because I don't know where you get that,
Well, you would get it from the local fire agency. So most people know what their fire agency, who that is, and so contacting the fire marshal of that fire agency, each fire agency is responsible for their own, origin and cause reports. So for example, I know a lot of people are waiting for the Edgewood fire report, and I don't think that's out. And we all know that Rich Sampson would provide us with that. But I don't think they normally just, disseminate it. Fire agencies, send it out once it's complete to people who ask for it.
Oh, okay, so
that's
the magic word to use,
right? You have to ask.
You
have to ask for it, right?
Right, because we've had that with the PMAC Council, for the little fires like out at the mushroom farm and this and that. And when we have CAL FIRE at the meetings, people ask, but otherwise there's no stuff forthcoming off the
Yeah,
top
for,
of their
for
head.
San Mateo County, if you want, a cause and origin report, I would just go to Rich. I would email Rich directly. You can email me and I can, get it from Rich, or at least forward your question to Rich for you. If you live in an area that's LRA, contact your fire marshal, Rabbit City Fire, Central County Fire, whoever that may be, Woodside Fire. They all do their own reports.
And if you get an answer, folks, send it to the group and then we'll all know.
Yeah, we don't have a lot of, a lot of fires, so we're not used to, reading these reports and seeing these reports, but I'm not sure if the CAL FIRE website has a list of, they probably don't, of these fires. So yeah, I don't think they list that information.
Sometimes you have to do an FOI to get stuff out of them. So.
Yeah, exactly. So yeah, Zeke's a great resource, and I hope everybody learned a lot today about modeling. I mean, I thought it was important because I've had experts come and do modeling for me, and then we've had fires, and it's night and day. It's like, well, wait a minute. The data is just, the results are not what the model showed. So I just want everybody to beware. If you're relying solely on modeling, I think you're going to be disappointed. So, okay. Well, with that, our next meeting is August 10th. And we are going to be hearing from RCD on the El Granada scoping project, which is pretty important to a lot of the mid-coast folks. So with that, thank you all for attending, and we will see you next month.